In the previous video, we learned how to use the substitution method for solving, and then we looked at a couple of examples. Now you will notice that the methods are similar to what we did with straight lines or equations in 2 variables and 3 variables. You have a substitution method, but then sometimes it's smarter to eliminate a variable directly. And let's look at this example. We have one familiar object here, which is a circle, and we have something that's not familiar. Now, an important thing for a circle is that it's only x squared plus y squared, no numbers in front of it. Okay. Now this, if you plot, actually comes out to be ellipse. It's like that. A circle is a special case of an ellipse. Now the first thing to notice here is that they both have y squared. So I can eliminate this by subtraction. So go ahead and subtract. 4x squared minus x squared is 3x squared equals 3. X squared equals 1. This gives you x is 1 and x is negative 1. Now you plug that back in. So you get 4. 1 squared plus y squared is 13. Giving you y squared is 9. Giving you y is 3 and negative 3. Similarly, this gives you 4y squared. Negative 1 squared is still positive, so you still have y squared 9 and you still have y 3 and negative 3. So now you have to be careful here about how many solutions you have. What this says is when x is 1, you have two values of y. So from here, the solutions that you get are 1 comma 3, 1 comma negative 3. And then when x is negative 1, y can be 3 and negative 3. Now you will notice a certain sense of symmetry here, right? The numbers are the same. It's 1 and 3, and you have all possible signs of plus and minus in them. Why that is so is if you draw an ellipse, and if you draw a circle such that they have two solutions, there's going to be this symmetry. Again, because of the equations. These points actually are going to form a square. It's interesting. They form a square. So in this case, the number of solutions you have is 4. Yeah. So you have 1, 3. You have 1, negative 3. You have negative 1, 3. And then you have negative 1 and negative 3. What this means graphically, remember when you have two lines, you have three possible cases, right? You can either have one solution, you can have no solution, or you can have infinitely many solutions. Similarly, if I have one straight line and parabola, I can have two solutions. That's if my quadratic has a root in real numbers. It's one solution and no solution. So in this case, you don't have the infinitely many case possible for one straight line and one parabola. A straight line and a circle, again, you can have two solutions. You can have one solution or you can have no solution. Two circles, two solution, one solution and no solution. What about two ellipse? Now ellipse is a special circle, so it should be the same. So you have two solution, one solution and no solution. On circle and ellipse is interesting because you can have two solutions, you can have one solution, you can have no solution, but then you have this additional which is 4 solutions, which is the one we saw in our example. Okay, that's the end of this topic for solving nonlinear equations.